So this lesson is on recognizing statistical questions. So our goal is to identify and write statistical questions. So we are going to start with example 1. So here it says, Mr. Borden asked his students a question and recorded the data in the table. What question did Mr. Borden ask? So the whole lesson is on statistical questions, and we need to determine whether or not it is statistical or not. And you might be wondering, well, what is statistical? And what is a statistical question? Statistics deals with a collection of data, and the data is going to vary. So a statistical question, when we ask that, we're going to have variability in the response. So what that means is there's going to be a range of responses. The way that the question is going to be answered is different based on who you are asking. So an example of this is if I ask everyone in the class what is their favorite color, everyone is going to have their own unique response. But if I ask, well, what is Miss Porcelli's favorite color? It's blue, okay? Every single time that answer is going to be the same, no matter who you ask. So if I ask everyone in the class, what is Miss Porcelli's favorite color, everyone should be answering the same thing. Now, if I ask the entire class, everyone's going to have a different response. So you really have to think about if the question is going to have the same response for everyone, or if there's going to be a difference or a variability in the response from everyone. So here, looking at some examples that they have what is the area of an 8.5 by 11 sheet of notebook paper? Now, an 8.5 by 11 sheet of notebook paper, everyone's going to answer the same thing for that one. So this one would be not statistical. The second one, how many sheets of paper did you use last week? Now, that could change based on who you're asking. I don't expect you to count how many sheets of paper you use, but that would vary based on everyone that you ask. So this is going to be statistical. The last one, did Bill use notebook paper to write his book report? Well, that's either going to be yes or no answer, and it's going to be the same no matter who you ask, so that's going to be not statistical. Okay? So in this table here, you'll see that it says sheets of paper used each week, number of sheets, and number of students. This is called a frequency table. You have data and then tally marks for how many people use that response. So here, 5 sheets of paper used, only 1 student used 5 sheets. 10 sheets, 1 student. 15, 2 students. 20, 4 students. 25, 6 students. 30, 5 students. So for this table, how many sheets of paper did you use last week would be a good question. And that is statistical because, again, you're going to get a different range of responses from the group of people that you are asking. So let's go ahead and look at example 2. Or actually, there's a try it problem, so let's go to the try it problem first. So is the question, was the high temperature on March 8th of last year a statistical question? Explain. So you need to ask yourself, is everyone going to respond to this question the same way? Or will I get different responses from different people? So what was the high temperature on March 8th of last year? And this is going to be not statistical. And this is not statistical because everyone's going to answer the same thing. If the high temperature on March 8th last year was 65 degrees, everyone would respond with 65 degrees. It's not going to change because we all live in the same area. Okay, so that was that try it problem. So now we're going to go ahead and move on to example 2. So let me go ahead and bring that up. So example 2, it says, Lucia surveyed the students in her class and made a dot plot of the results. What question could Lucia have asked? So whenever we look at a dot plot like this, you might have seen them in the past, but we need to read all the information that's given so we could digest and understand what's being represented here. So the title here, it says Students' Weekly Exercise and down here it says number of days. So 0, 1, 2, 3, 4, 5, 6, 7 days, and weekly exercise, these dots represent one person. So one person exercised 0 days. One day, we had 3 students exercise one day. On 2 days, we have 5 students, 3, 4 students, 4 days, 4 students, 5 days, 3 students, 6 days, 0, and then 7 days, 1 student. So this dot plot shows the number of days different students exercise each week. So we need to think of a statistical question that would represent this piece of information, this dot plot. So a statistical question that Lucia could have asked would be, how many days do you exercise each week? And everyone would respond a different way. Okay, so our question is, how many days do you exercise each week? Now, you could have asked a different question as well. You could have said, how many days don't you exercise each week, or something like that, as long as the responses are different from each people.
I need the teachers who have a cow on the cow chart.
So we're going to go ahead and move on to the try it problem at the bottom. And I apologize, there's an announcement going on at school, so just give me one moment, and then we'll go through this one. Okay?
Paper training, there's
so another statistical question that Lucia might ask, and I kind of just went through this, what days, or how many, I should say how many days do you not exercise?
And I will see you in the hallways. Thank you very much.
So how many days do you not exercise in a week? So how many days do you not exercise in a week is a good example. Now, there are many different examples for this, but that is just one. You might have thought of another one as well. So I'm going to go ahead and move on to example 3. And again, I apologize about that announcement. Hopefully you were able to hear what I was saying. So example 3, Dante surveyed students to see how they feel about a proposal to choose a new school mascot. The frequency table shows the results. What question did Dante likely ask? Is this a statistical question? So here we want to look at our picture and kind of digest what's going on here. So it says Lincoln School alligators. There's a picture of an alligator here. It says yes and no, and then we have some tally marks. Yes, the tally marks, there's 22 of them. No, 18. So here you can just come up with a question. The book says, do you want a new mascot? And the answers to that are yes or no, but everyone might respond differently. So there's more than one possible answer here, and it's statistical, so that would be a good question. You could also say, do you like our school mascot? Maybe their alligators they're already the alligators. Do you like the school mascot? Do you want to change our school mascot to the alligators? So, excuse me, there are many options for this example. In order to be statistical, remember it has to have variability. There has to be a range of responses. So everyone should be responding differently. Yes, it's a yes or no question, but people can respond differently depending on their opinion. So down here, for the try it problem, it says, how could Dante change his statistical question so that there would be more than two possible answers? So we don't want a yes or no question anymore. So go ahead, pause the video, and take a moment to think about what statistical question there could be here. So one example would be, what new mascot do you want? So this is something that could change based on everyone. You could say, maybe you want to be the Panthers or the Tigers or the Lions, or maybe the Bulldogs. There's many different answers for this. So that would be a good question that you could get more than two answers for. So here, You can have many different questions here, but that is just one good example. Okay? So moving on to the key concept to recognize and write statistical question, determine whether the question has one answer or several different answers. Statistical questions have a variety of different answers. So how many nickels are in a dollar? Not statistical. Everyone's going to answer that question the same way. Which former U.S. president appears on a nickel? Everyone will say the same thing, so that's not statistical. How many nickels do students carry in their backpacks? Now that may change by person, so that's going to be statistical. Okay? So we're going to go ahead and look at the do you know how. There's a couple examples down here. Go ahead and pause the video to determine whether or not they're statistical or not. So go ahead, take a moment, determine if they are statistical or not statistical. So in which months are the birthdays of everyone in your class? That is going to be statistical because that will change and vary by person. Does Sue wear glasses? Not statistical. Okay, that's either she does or she doesn't. Everyone will say the same thing. Who is the current President of the United States? That's not statistical. Everyone will respond the same way. How tall are the students in grade 6? That would be statistical because you're collecting some data and that's going to vary by person. What is the least populated state? Not statistical. Everyone will say the same thing. How many fish are in the pond? You just need to count. Everyone's going to say the same thing, so that would be not statistical. Okay, so remember, for statistical questions, you are going to get a range of responses, or it has a variability in the responses in order for it to be statistical. If it doesn't, then it is not statistical.